So I want to go over transition and transversion mutations because there was confusion in how exactly they came about and just the mechanism. So I'm going to go through that. This right here is a strand of DNA that's complementary base pair. We're just going to focus on the C and the G. So I'm going to label this cell 1 because this is the cell just in its normal state. What happens is it's a spontaneous mutation where the C will accidentally pair with something else. Say it changes chemistry and now it can pair with an A. And so this right here, this is a temporary thing. That's something that students were getting confused with. This is only temporary. And so this is mispairing, and this is a spontaneous mutation. I'm saying it's spontaneous because if you're induced, that would be, if we think about the Ames test, so that would be an induced mutation. So this is still cell 1. It hasn't done anything yet. This is cell 1, still cell 1, so I'll label it again. But what happens is the cell's going to go to replicate. And so when you replicate, both strands are going to be used as the template or as the parent strand. So we have a C, and then we have our other strand, which has our A in it. And so this strand will be fine. When it goes to replicate, it'll pair a G, and that's what you want because right here, the CG, that's what you want here when you're replicating. You want it to be an exact replicate because this is when you're going to replicate. Replication. But this A is what poses a problem. So this A is where the G should have been, but now the A is going to have a T pair with it. It's going to make this T come about instead of the typical C. And so everything else gets paired well, and so both of these are replicated. But when your cell goes to divide, I'll label this one cell 2A, and this cell 2B. This cell has the CG, which is what we wanted, but this cell has TA. And so that means that this mutation, CG to a TA mutation, and then to figure out if it's a transition or transversion, you compare the bases to what they should have been. So this strand right here is the same as this strand, besides these just two base pairs. So it's a C to a T, and so a C we know is a pyrimidine. We know a T is also a pyrimidine. And so if you go to pyridamine or purine to purine, that's a transition. So this here is a CG to TA transition mutation.